Okay, welcome back everybody to another topic of geometry related to triangles. This time we're going to talk about the medians of a triangle. So we'll have some vocabulary today and one theorem which we won't prove, but we'll talk about it, and some examples to get you on your way to understanding how to use this theorem. So first, some vocabulary. Let's talk about what concurrent lines are. So concurrent lines are three or more lines that intersect at a single point. And that point is called the point of concurrency. Point of concurrency. Okay, now here's what the topic is about today, the median of a triangle. So what is a median of a triangle? So a median of a triangle is a segment whose endpoints are a vertex of the triangle and the midpoint of the opposite side. So in my diagram there, you can see that segment CD is a median of the triangle because it connects a vertex of the triangle with the midpoint of the opposite side. And so we know that a triangle has three vertices, so it would have three medians as well. So every triangle has three medians, and the medians are concurrent. So every triangle has three medians, and when you draw them in a triangle, they come together at a single point. They are concurrent. And that point where they come together, and you'll see this here in a minute, but the point where they come together is called the centroid. So the centroid is the name for the point of concurrency for the three medians of a triangle. Centroid. Okay, so here's the only theorem we're going to have today. It's called the centroid theorem. And we're not going to prove it, we're going to state it, and hope you can kind of work with it. So the centroid theorem says that the centroid of a triangle is located 2/3 of the distance from each vertex to the midpoint of the opposite side. So if you take your point A right here, and you travel from point A to point Y, 2/3 of the way from point A to point Y, you would arrive at the centroid. And that's true for every single median of the triangle. So if you start from point B and you walk to point Z, 2/3 of the way you're going to stop at point P, the centroid. Same thing if you were to walk from point C to point X. If you start at point C and walk to point X, when you arrive at point P, that's the centroid. That's 2/3 of the way from point C to point X. So we write those relationships here off to the side. So AP is 2/3 of AY. Likewise, BP is 2/3 the length of BZ. And for the third median, the length of segment CP is 2/3 of the length of segment CX. That's what the centroid theorem is telling you. So we just have to know how to use that. So I'm going to give you a couple examples to put this into practice, and then hopefully that'll be enough that you can work on the assignment. Okay, so here's triangle ABC, and I've drawn the three medians. AF is a median, BD is a median, and CE is a median. So those three medians, remember, are concurrent. They meet at point G, which is a point of concurrency. So the centroid theorem says if you travel from A to F, 2/3 of the way you're going to be at point G. So 2/3 from C to E is, again, CG. From the vertex to the centroid is 2/3 of the total median. And likewise, from B to D, 2/3 of the way from B to D is BG. So we can take that information plus some of the information that they've given us here and solve these problems. So they want to find AG. So if you look at our picture, AG is right here. So that's 2/3 of AF. So all we have to do to find AG is just understand the centroid theorem. So AG is equal to 2/3 of AF, which we know is 9. So 2/3 of 9 is 6. So we know that that piece right there is 6. Okay, no problem. No problem. Okay, let's do one more. GE is 2.4. So if we look at that, that's right here is 2.4. Just going to write that on there. And they want us to find CE. So they want us to find this segment. Well, we know that 2.4 is 1/3 of the total, right? Because from point C to point G is 2/3, and from G to E is 1/3. So because 2/3 is exactly twice as long as 1/3, we'll just double the length of GE. So double 2.4 is 4.8. So this piece right here is 4.8. Right? Because of that 2/3, 1/3 relationship. So if you want to find CE, then all you have to do is add up those two segments. So take the 2.4 that we were given, and we're going to add to that the 4.8, which we found because of the centroid theorem, and just add those up. So 2.4 plus 4.8 is 7.2. So the length of segment CE there, the green segment, must be 7.2. Okay, so that's what you need to know. So to kind of summarize what we talked about the medians of a triangle. The median, remember, is a segment connecting a vertex with the midpoint of the opposite side. There's 3 of those medians in a triangle. They meet at a point, which is called the point of concurrency. And the centroid theorem says, and that point is called the centroid, and the centroid theorem says that that point of concurrency is 2/3 of the way from a vertex to the midpoint of the opposite side. So if you can remember all that and put that into practice, you should have no trouble with the assignment. Okay, that's it for now. Good luck.